Ninja Incident Report, May 18, 2026. In May, one attacker group was found to have planted information-stealing code inside several legitimate software components. And among the targets, for the first time, was an AI toolkit, the set of tools developers use to build AI features into their software. That's the point worth making. Supply chain attacks, attacks that slip malicious code into the distribution path of software components, have moved beyond ordinary general-purpose libraries and into AI development kits. As more software is built on AI, the components underneath it are themselves becoming the entry point. The same group poisoned two kinds of components. One is node-ipc, a general-purpose library that lets programs talk to one another. It has nothing to do with AI. It's an ordinary, widely used library, downloaded roughly 530,000 times a week, used directly by more than 400 projects, and reaching into the thousands counting indirect use. People who've never heard the name are using it without realizing. The other is Mistral AI's official development kit, the Mistral AI package, version 2.4.6, the toolset AI developers rely on as a foundation. A general-purpose component and an AI development kit, poisoned by the same group, the same method, at roughly the same time. Here are the known facts, per SlowMist's analysis. When node-ipc was detected on May 14, the Mistral SDK on the 16th. The victims are developers and automated environments that use these components. The attacker is TeamPCP. 3 legitimate versions of node-ipc, 9.16, 9.23, and 12.01, had about 80 kilobytes of obfuscated, deliberately hard to read, credential-stealing code added. The Mistral SDK had the same kind of code. The link to one actor, both carry the same technical fingerprint, an identical key, and SlowMist attributes them to the same group. And how? The code was appended to a file inside the component, and it runs automatically every time a program loads it. Once it runs, the injected code does 4 things. It looks for cloud keys, the keys and passwords that prove this is me to a cloud service. It looks for the secret keys used to log into servers. It collects various passwords. And it sends what it collected out to the outside, hidden inside ordinary-looking network traffic, so nothing looks obviously wrong on the wire. The node-ipc timeline runs like this. The attacker gets into the distribution path, at a time not yet known. The 3 poisoned versions are published to the distribution source. Soon after, the anomaly is detected, and the injected code across all 3 is confirmed identical. 24 hours later, SlowMist publishes its analysis, and the poisoned versions are removed. So this is not a case that spreads silently, undetected. It was detected, and it was taken down. But there was real damage. Cloud keys, server keys, and passwords were sent out, and the node-ipc exposure alone spans roughly 530,000 downloads a week. 2 things remain open. Secondary damage is under investigation. How far the follow-on intrusion went using the stolen keys is not yet established. And the monetary loss is undetermined. This isn't an attack that drains assets directly. It steals keys, and any financial damage comes afterward, as a second-order effect. There's no figure at this point, so none is given. This is not an isolated incident. SlowMist calls the group TeamPCP and the program Shai-Hulud. The same group hit a general-purpose component on the JavaScript side source and an AI development kit on a separate Python side source. At roughly the same time, a parallel attack across 2 distribution sources and 2 programming languages. The new element this time is the AI development kit among the targets. The more software and automation is built on AI, the more broadly the poisoning of the underlying kit spreads. And this group published its stealer in a form anyone can copy and spread further. Comparable precedents include EventStream in 2018, which targeted crypto wallets, and UA-Parser.js in 2021. In each, it wasn't a fake package, but a hijack of the legitimate path, shipped as the official version. For perspective, set this beside the recent Axios incident from March 2026. Axios was an account takeover by an individual attacker, one component, exposed only briefly. This time, one group reached across multiple distribution sources, hid not only a general-purpose component, but an AI development kit, and published the attack program itself. Both share the same collapse, the assumption that a legitimate name means it's safe, but they differ sharply in scale and in how far the target reach extends. So what can you do now? If you were using the affected node-ipc versions, or the affected Mistral SDK version, remove that version and rotate your cloud keys, server keys, and passwords, regenerate and replace them. Understand that the idea component with a legitimate name is safe did not hold here, because it was the real path, not a fake one, that was poisoned. And pin the versions of the components you use. Don't jump on a new version the moment it appears. Beyond that, only the direction this should go. Stopping the moment poison enters the distribution path, before the fact, is hard. If that's so, then rather than fully trusting a legitimate name or path, what's needed is a layer that can catch and stop behavior at odds with what a component was designed to do, a component that's supposed to handle communication, or to serve AI, instead reading keys and sending them out. Hold, in advance, a notion of what each component was supposed to do, notice when behavior departs from it, and stop it there. This class of attack calls for exactly that kind of defense. The concrete design will be covered separately. To close. In May 2026, the group TeamPCP poisoned a general-purpose component, node-ipc, detected May 14th, and Mistral AI's official development kit, detected May 16th, using the same method. Cloud and server keys were sent out. Detection and takedown happened, but the secondary damage and the monetary figure are still under investigation. The one thing that stands out most, the target of supply chain attacks has widened beyond general-purpose components to the AI development kits, the foundation that AI itself is built on. How to defend against it will be covered separately. This report is based on the threat analysis by the security firm SlowMist, and confidence at this point is moderate, with the investigation still ongoing. Where something isn't established, we've said so. Check any contract at the Ninjaskin bot on Telegram. Proof of concept, investment, and grant conversations are open at the usual address. The defense design comes in a follow-up. See you then.